of outside entities. At the end, you see looking at off. There's still a sentiment to bring it off. I don't think it is. To be honest, incredible. Yes, it's right there. No, exactly. No, I totally agree. With hindsight, just using this answer.
Good afternoon. This is the payload session. I need a note taker. Is anyone volunteering to take notes? Okay, Stefan, thank you. Anyone else who's, because today I'm chairing by myself because Ali is not here. So I would be happy if someone else or another person took some notes. You'll do that both. Okay, thank you. So, and Jonathan will be in the Jabber. Okay.
We could really cook the books we do now. We just have to hack into the audio database and then we could cook the books.
Yeah, we could all decide we want it anyway.
Okay, so that's the note well, and I think by today everybody's seen it. I hope it's not your first session in this meeting. The agenda. Oh, Monday, I forgot to change. That's the cut and paste stuff. We have the. No, I know what's the problem is. I have the wrong presentation. Sorry about that. Wrong. Yeah, it's from the previous meeting.
You have to do it again.
Sure. Payload. Okay. The note well didn't change. Okay, so this is the agenda batch for today. We will have the payload status update, then the FEC presentation, the VP9 video, and a payload format for interleaved packets. And hopefully we'll end earlier, so we'll be able to go to the social. Document status. RFC published, it's not correct because we have the G711.0 was published already as RFC 7655, so we have an RFC published. The other in the editor queues are the RTP how-to and the VP8 payload. We have in ISG processing the RTP H.265.14, and I think, Stefan, we are waiting for the security to, I think it's also, I talked with Ben about it.
Yeah, Stefan, I think the main issue is security consideration section. There was also this IPR thing.
Mm-hmm.
On that, Stephen said he will look at the markup that we produced.
Mm-hmm.
I haven't seen his reply yet. I expect that anytime.
Okay, thanks. And other documents that are not presented is the draft IETF payload, RTP, and ancillary data, and the MELP. The MELP was adopted as a working group document, but I need to put a milestone. We didn't have a milestone for that. Current milestone review. So we have three audio codecs that are there but have not been progressed, and we'll have to figure out what to do with them, whether to just remove the milestones or to see if they want to conclude this work. Those are the ones that's marked in red. We have milestones for the FEC. The MPEG-2TS, again, I'll have to ask Ali if he wants to really progress it because he changed his work and maybe he doesn't have any focus on that work anymore. And we have the VP9 video codec, the ancillary data, and we need to add one for the MEL. Okay, so this is the status of the working group. Now, the first presentation is on FAQ. That's who's presenting eventually. You're presenting. There's, I think there's this thing you can switch the slide.
Oh, I thought I was third on the agenda. But
Hmm?
I thought I was last on the agenda, but it's okay. Yeah, I guess that's why it's called that. Next slide, please.
Oh, this doesn't work.
So we presented in Prague, and there's a lot of there was discussion and side meetings, and we came to some resolutions. And the 0.1 draft has all those details in it. So we incorporated feedback from Prague, which was basically 3 items. One was that we would support multiple SSRCs, or protecting packets across multiple SSRCs. Reliance on SDP would be not for indicating how much of LND packets would be protected by SDP, and we updated the SDP registration to actually say FlexFAQ, because before it had this very long non-interleaved FEC associated to it. We added Giri as co-author, as he provided some text for updated for multiple SSRC support. Next slide. So this is just a recap of the changes that we accepted at the last meeting. One was the length recovery was moved to the top, and it's swapped space with SN base. We added an SSRC count, which tells you how many SSRCs are in, and because of that, we have something like 24 reserved bits, which can be used in the future, perhaps. Next slide. So one of the open issues that we had.
Hi.
You don't like the 24 bits?
I didn't care about the 24 bits. Hi, Colin Perkins. Are you going to say anything about how the multiple SSRC stuff works?
Yeah. So what we discussed last time, there would be SSRC count, and there would be blocks of these that would come, and there's an SSRC associated. So you would get, this number was 4. You would get 4 SSRC blocks, 1, then another, 2, 3, 4.
How do you recover the payload type and RTP header fields for the different SSRCs?
You would have to explain that.
I can't see how it would work unless they all, for example, have the same payload type.
No, payload type is through PT recovery.
So it's just the XOR of all of the PTs?
Yeah.
Just which data you use is different.
Okay. Right, okay. Does that work for the CCs and everything?
Yeah.
For the CC list as well? It's the XOR of them all. Okay. Yeah, okay, right.
Jonathan, I mean, the one thing here, which is a limited, I mean, I think it's fine, but we should probably call that as a limitation, is that this means that all the protected sources have to be in the same RTP session. You can't protect sources. I mean, the FAQ flow doesn't necessarily need to be in that same RTP session, though the SDP signaling that would be exciting, but all the protected sources have to be in the same session. So, yeah, right. So,
yeah.
So I think that's fine, but we should just maybe call that out somewhere.
Okay.
Mosen, so just to remind folks, the reason we were putting SRC as the tag for these things and able to just repeat a group of SSRCs is because we were already binding to the sequence numbers. So the sequence numbers are obviously very tightly bound to the source packets SSRCs.
Right.
So we already have very tight binding to the source packets SSRCs, and that's why we thought it was okay to go ahead and just be able to extend this easily to multiple SSRCs.
Yeah, since we had to put the SSRC in, so once you had one of them, adding more of them. But anyway, this was already discussed last time, so I was just reiterating what was already agreed upon. So I don't think we want to reopen that issue. I think the next slide kind of, so the last time we discussed, we said SSRC is okay for now. Could we put something else in there? And I think we don't want to. So I think I would just remove the editor's note and say that SSRC it is for now, and I'm not sure if there's any clear motivation to have something else there.
Magnus Westland, I think what's important in the draft is to explain that this makes it impossible in some cases to just forward FTC across middle boxes that rewrites SSRC for any of the streams it protects. Just to make sure that people really understand that, but it's
which is
exactly, and therefore you need to recreate it basically because you
have to go internally.
But you could also, like, if the loss, it depends where the loss occurs, but if the loss occurs on the way to the bridge, it would recover it. So
sure, but the problem is really if you have a middle box that rewrites SSRCs or sequence number or any field, you clearly can't forward this, but and then
you need to do some magic.
Yes.
For this too. Okay.
So I mean, I'm fine with doing this. I mean, FSC normally should be hop by hop anyway. So.
Well, now to clarify again, you'd have to not rewrite just the SSRC, but also the sequence numbers of all the packets in the FEC headers. So quite a bit of whatever RTP header operations the middle box is willing to munge for the incoming streams, it's going to have to munge for the incoming FEC as well.
That's quite a lot.
Just a question, but if you rewrite and you put the original SSRC in the CSRC, you still can figure that out. I mean, you have the mapping. I mean, it depends what you mean by rewriting SSRCs.
I think what Magnus was talking about was not just changing the SSRC, but also probably changing the sequence numbers as well.
Right.
Yeah, and the point really is that you need to recalculate them. And if what you're saying you put it in CSRC field, if you're going to do recover the lost packet on the way, you need to have to change the XOR to include the CSRC field anyway. So you have to recalculate at least the first part of that XOR, the data of this FEC packet anyway. So
I think this is a bit more complex than actually doing it on the mic. I think there are some concerns here that we need to.
I think especially primarily just document that yes, you can't just forward this across.
It won't be even sufficient in some cases to actually even just change the headers because there might be some impact somewhere else. So there you have bit masks and things like that, and you
have to recalculate things and all these things. Just saying that you basically have to terminate and reapply it on the outbounds is probably the right level, but warn people about that so they actually think about it.
I think that's a fair point. And is someone taking notes? Then that should be an action item that we should.
So I agree that the SSRC is the right thing. Do be clear what, if any, implications there are for the number of sessions. If this needs to be in the same session or if this has to be in a different session and this sort of thing to the original, just to make sure that's clearly documented.
Yeah.
Everything protected has to be the same session. This could be something else.
But make sure that if there are any restrictions on that, make sure they're clearly documented.
Thank you. We'll do that. We still have many more open issues. So next slide. This is easier. So this is another thing that came up. We don't have a way in SDP to say what mechanism we're using. We presumed it was XOR when we started with the draft. Then now that we're doing several SSRCs, it comes up if you want to use Reed-Solomon or Raptor or something else. At least there is some motivation to do it. The motivation is thus far to do it in SDP and not in band. So perhaps it just needs a code point in the SDP signaling saying that this is XOR or Reed-Solomon or something. I went about looking for an INR registry which would actually say what has been done. I got a pointer to one, which is this. I'm not sure if it captures everything that we want. Definitely does not have XOR in it. So the question is, should we make a registry and just populate it with a bunch of things in this document?
I'd say make a registry and populate it with only the things you actually want to use at this point.
Right.
If that's make a registry and populate it just with XOR, that's fine. If you actually, and I think it should be more than just here's the name. I think it needs to be, and I mean, I'm not sure what the IANA policy is, but I think probably at least specification required, and thus, explain how you actually use it, not just, here's this FEC scheme that exists. You figure it out.
Right. Okay. Yeah. Well, we do a fair bit of explaining how XOR works in this draft. So,
Yeah.
so right.
Yeah. I mean, it's considering that, for example, with Solomon Raptors have different block sizes and all these considerations.
Yeah, so
you need to determine how you actually set the block sizes and things like that, and then strips. Because I mean, you might actually have multiple symbols per packet rather than having one packet as a symbol and things like that for certain codes.
And I agree that you would need a way to like figure out how this RTP header payload format works with those things, and like what you need to.
So you need a specification.
Yeah, definitely. So the guidance would be like to build an IANA registry in this document.
Well, I mean, why? It's much easier if you want to have a Reed Solomon version of FlexFEC, then you define the Reed Solomon FlexFEC payload format and give it a new payload format media type. That's just
okay.
I mean, there's no need to have.
I came up to Colin Peggins. I came up to see what he just said.
Okay.
Right.
Me too.
Just call this parity FlexFEC, and say that it only works with parity FEC and the XR stuff. And if anyone wants to define a variant which works with Reed Solomon, they can copy paste it, change the name, and specify any additions.
So it's not even a space separated, but it's
just the MIME type will be parity FlexFEC.
Okay.
Or
Not
XOR
like
FlexFEC.
FlexFEC space.
No,
Not a parameter.
Okay,
just
not a
name.
parameter.
Yeah.
Okay.
Yeah, just part of the name. Or just call this one FlexFEC and let them call. But I mean, having parity in the name would be fine. I don't care whether it's in the name, as long as I think this one should just be for XOR. And if you want one for something else, make it a different.
Okay.
We don't need another level of indirection. It can be, MIME type names are cheap.
Yeah, is there?
So we had a SDP parameter for code equals XOR. You don't see that as being sufficient already?
It's unnecessary.
Why is it unnecessary?
Because you need MIME type.
So you use the MIME type instead to indicate which code. So for every new FEC code you use, you just give it a new MIME type.
But this is not a different, there's no different RTP format for this. It's the exact same RTP format. It's just a different code inside.
No, because how the output.
We're not going to have a different header.
No, not the header, but the output data is not going to be the same. So how you structure the data that goes into, and that's why it's much simpler to just use the MIME type to indicate, oh, this is the derivant of this, but there's no, because you need to have the special processing for each FEC code, you can just as well put that information into the MIME type. That's the point.
So we definitely need a different specification for each of the FEC codes, but that's not necessarily a payload format specification, because there is the payload section of it will always just be a FEC code applied to the payload. The header sections are all going to be unchanged. The recovery operation can be described in a separate spec, but that doesn't need a separate payload.
That's what a payload format is.
No.
So Colin Perkins, so just because the syntax of the header is the same doesn't mean the semantics are the same. And the semantics are completely different because using a completely different protection operation, we already have a way of giving it a different name, which is to give it a different media type. People would not say that MuLAW and ALAW are the same thing, right? They're different payload types. They have different payload type names, even though the headers and the same. Well, in fact, they don't have a header, but
the data is the same.
But it's encoded differently, and it means something different. Yeah, we have a namespace for these. It's the media type name. Let's use it.
Stefan Wenger, I also agreed. We have that over structuring our document structure by having a FEC payload format that lives in a payload format. I mean, we have done that. We have gone down that route in both in RMT and both in FEC frame, and in either cases, it's not particularly pretty. So I would also say let's keep it simple. And if we have a little bit of copy paste between documents occasionally, who cares?
So not again. So I don't mind more specifications. I'm happy to write more specifications and do that. What I'm more worried about is having more complex negotiation, more complex SDP. Now we're exhausting payload type space again. It's not the same. So now if I want to offer XOR, Reed Solomon, and Raptor, I'm going to create 3 new payload types and have to bind all those 3 payload types to all of the different source streams.
You would anyway.
No, if you read the draft, the proposal was to have the code equals parameter with 3 options, and the answer picks one of the codes.
Payload type for each one.
Why?
So you can distinguish them.
No, the SDP offer answer establishes the code in use. And then there's only a single payload format in use at that time. And it's the code that applies from offer answer. That's what was proposed. I think it's already even written up in this version of the draft.
I might have removed it in the previous 2 versions because I think we didn't have consensus on it. So, but there was in the original, I think, this draft sync version of it.
I just don't see the advantages of listing multiple payload types for all the different codes and then enforcing the complexity of it.
So how do we signal this? You can't pick FMTP parameters in offer answer. You can't subset them unless you signal a different payload type. And this has to be an FMTP parameter because it's a MIME parameter, and that's how you signal MIME parameters.
There are no rules at all for FMTP parameters. What do you mean?
Yes, there are.
Have you looked at H.264? None of those parameters in H.264 have offer answer semantics that are exactly per some SDP spec. They are completely unique to that spec. And if we had a parameter that said code equals XOR, comma, RS, comma, Raptor, the answer could have rules that say it must subset that with code equals XOR or Raptor or RS, and it can't answer with more than one. As a matter of fact, I believe H.265 is already doing something like that for TX mode, isn't it? Yeah, X265 is already doing that in its payload format for the transmission mode of MRMT.
This just makes no sense.
Well, anyway, we can defer this topic because we don't have Raptor or Reed Solomon in the spec yet, so we can wait on this part.
I mean, the major question, I mean, is what is this? If you want to do IANA registry and register those as MIME types, then you have to.
Yeah. So, I mean, I
decide.
guess the first question I have is: anybody actually want to do anything other than XOR? Because I mean, if we're arguing about something which nobody's ever going to.
We're actively doing
Okay.
Reed Solomon, and Gary added as a co-author to do Raptor.
Okay. So in that case, I guess my other question is, I mean, I was under the impression that different formats have different constraints on how, like, what patterns you can do across the inputs. So I think then you would want them to have different headers because, like you can't just, certain things you could describe that XOR could, certain patterns that XOR can describe, other things can't describe. So there's no point in having a mechanism for something that you can't describe.
I think the bitmask covers those cases, at least from my understanding for the Reed Solomon. I can't speak for Raptor. Haven't seen that piece yet. So.
Yeah, I mean, I'm certainly. Yeah, I mean, I certainly think
they're all stream based, so I would imagine that the header would work.
Okay, yeah, I mean, I don't certainly see what why. I mean, what I want to say. I mean, I guess I don't really see what the benefit is to sort of negotiating it. I mean, I think it's cleaner to have them be separate payload types. Just say, here's, and then if you wanted to use 3 of them, I mean, maybe there's no point to that, but you could.
Should we take this to the list, because it seems that at least there is definitely some.
Okay, so I think. Okay. So
May I get one more comment on this? So, okay, I'm always right that this would save going from like 3 payload types to 1. Having removed the other restriction, I mean, if we can get rid of all this combinatorial explosion for the payload type, which we are doing, then I don't see this restriction. I mean, this increase in number of payload types is significant because this was expected to be used. And I think, yeah, that's really, I don't see that gaining us that much. So.
if we have a general problem with running out of payload type numbers, then we should find a general solution for it rather than trying to
That's what
fudge
they're
around
trying
it
to
in
do,
particular formats.
RID.
So RID, Mosin, again, RID doesn't solve this problem. So we have the combinatorial explosion in multiple dimensions. RID solves it in the constraints dimension, in the limiting certain resolutions in that dimension, but it doesn't solve it for. Yeah, if you want to protect this payload type and you want to bind it to some others.
Yeah, Jonathan, yeah, you only need one per session per spec scheme in our argument, because these don't bind to payload types. You use this flex spec is designed to protect every payload type in a session. So you only need one instance of payload type per session, one instance of flex spec per session.
Yeah,
so it's nothing combinatorial. It's not combinatorial.
Okay, so
did we make resolution now?
Just one other idea. I mean, if we have a finite set, we could also just spec them all out now. Now meaning in the first iteration of the document, make them all mandatory to implement, signal them in band, be done. Right? We are not talking about rocket science here. And frankly, the IPR thing about Raptor, that's not so much my problem either. So perhaps that's the easiest way. Avoid negotiation by simply requiring everything.
It might require negotiation because the other side might not understand.
So
make them all mandatory to implement.
actually, I'm willing to write up the Reed-Solomon part, and Gary was added as a co-author to write up the Raptor part. So I'm actually fine with Stefan's proposal.
No, but it means that you cannot negotiate it because. No, but I don't think you want to have all of them mandatory.
Well, there's a practical problem that I don't think RTC Web is going to want to mandate anything beyond XOR. So we can't make them all mandatory for anybody that implements Flex Spec, because I don't think the RTC Web specs will want to mandate all three. I don't know, maybe Justin has an opinion on it.
I think we should stop.
Would want to.
I think we should stop the discussion at this point and take it offline. I mean, to finalize this the solution. I mean,
so the open issue 2 would. To my understanding, it's unresolved, and we will put it on the list.
Next one.
While going through the draft, when I was doing some cleanup, I realized that there was some ambiguity on what the 0th bit on the bit mask implied. Was it SN base, or was it SN base +1? And I looked up a bunch of run length encoding where they presume it to be SN base, and some previous documents presume this to be SN base +1. So without having a clear pointer, I was not sure which way should we lean on this one.
Magnus Westlund, can you go back to the header picture?
Yeah.
So you have a sequence number base per SSRC.
Right.
Logically, you should include then the first packets you include would be SN base. So you don't actually need to spend 1 bit on the bit mask on that.
Okay. So the 0th bit is the offset.
Yeah.
Yeah. Okay. +1 to +1. Cool. Yeah. I just wanted to make sure that this was what we wanted, because next slide is, so if your SSRC count is 0 and bit mask is 0, or M or N is 0, it becomes a retransmitted packet. And I believe this was desired last time. So do we document this as a part of the spec, saying like I do call it out right now, but do you want some more text to say it normatively, or just say it could be used, or it can be used, or it may be used as
it just falls out from the definition of the spec, right? I mean, whether or not you call it out, I mean, that's how it works. I mean, if you want to add a note that says, by the way, this is what it means.
This is how I do it right now. I'm wondering if there needs to be more specific guidelines around it.
Well, I mean, you can't prohibit it without changing the spec. So it's going to be there, and people will be able to use it, whether or not you write anything about it.
Mosin, I think the question is around whether we need more text beyond the payload format about how a retransmission would work. Like, do we say using any mechanism like NAC or anything else to generate it, or do we need something specific and new to trigger this on-demand FEC packet? I think that's what other text
like, of course, you
is
could send it.
necessary
The question is,
to say how the overall mechanism for retransmission should work.
So I don't think the NAC feedback packet specifies a response.
It doesn't. No. I mean, should this document specify overall how a retransmission would work in operation, not just how this draft would encode a retransmitted FEC packet, but how a receiver would ask for a retransmission on demand from a flux FEC capable sender? And whether there's a rule, if you negotiate both RTX and FEC, which one should end up being sent?
I mean, if you've negotiated support for both, then presumably you could send either. Why should you need to specify?
This is the question.
Magnus Preston, I think the interesting question is actually not in this direction. It's rather saying, I can't remember. Sorry, I don't remember if you have a parameter the limiting how big buffer or how big in time, or if you can restrict it down to saying, oh no, don't really XOR it, but just send this retransmit this packet.
There is an SDP a buffer time window.
Yeah, I mean that's for the buffering, which is needed for retransmission FSC. But if there's a signaling for restricting this to only be used as a retransmission rather than being used for XOR, but I guess it doesn't really matter if you have the functionality for this. You can do FEC and you could do retransmission with or an XOR over something, so including the last one. So
do you want to propose some text for that small bit that you think is missing, so that we could see if we?
I don't know if anything is missing. This is a question, and most likely we actually don't need to specify anything. But so
okay,
it's gonna work in the.
Yeah, Jonathan Lennox. I mean, one of the reasons why you might want to call this out is because it does actually solve one of the combinatorial explosions. Because if you can remove RTX from your M lines and use this instead, it solves a combinatorial explosion in your payload type numbers. I mean, at the cost, of course, of header, which might be a problem for video where you're close to MTU. So that's potentially an issue. But
yeah. What I think we have to be careful about is people implementing just the subset of this which allows retransmissions, because that doesn't necessarily buy us anything. So saying you have to implement everything, but you have to be able to receive any combination of these. But people can use it to only send you retransmissions. Because if we start allowing people to subset it, we get more parameters and more different ways of doing things. And
yeah, because that would be just XOR, and then XOR doesn't send you anything to XOR, right? So
still seems like a improvement over the status quo with RTX to me. So
I think using this to do a retransmission is a perfectly reasonable thing. What I would not like to see is receivers that can only receive this when it's used as a retransmission format.
So they don't implement the XOR.
They don't implement the XORs or anything.
And they just see this and they say, oh, I see a bunch of other things in it and I will not do anything because the bit mask was actually set in this case and I don't know what to do with the bit mask. If the bit mask was 0, then I would know what to do with it. Damn coders.
I agree that would be sad. I hope anyone who implements this would at least implement XOR, but it would
it's not that difficult.
It would still be an improvement over the status quo.
Okay. Okay.
Yeah, oh, so there comes the normative text that I might have been looking for.
Okay. Okay, so we're okay with that.
Yeah, now
can you summarize what's the resolution for this fall?
For the notes, he wants to summarize the conclusion.
Yes, let's do it. I think that's the summary.
And maybe some text about what Colin has said.
Colin said must not do.
Let's not subset this back.
Yeah.
Yeah. So just
Can you say something like that?
What would be the total overhead if we do this for RTX?
I think there's go back 2 slides.
Here.
I think 64 extra.
64 or 80?
64 plus I think SM base is yeah, so something like the
80 as opposed to 16.
Yeah, that's kind of sad. Like, it'd be nice. Like, we might. Like, as Peter said, like, anything would be an improvement of the status quo, but like, it would be nice if we didn't have to choose between like being efficient and like just getting the thing that would be nice, which is the PT. We had just 8 more bits. We could get rid of the whole like payload type of combinatorial thing. I'm not sure I want to go like 60. It's got sequence number and like I think that might.
This is sorry. The overhead here is confusing. There's no overhead for the beginning because those are all those you would have in the RTP header anyway, right?
No, that's different. That's the FEC header in addition to the RTP header, because that's the.
No. Payload here does not begin RTP header. There's no RTP header starting at the payload after this. That is the RTP header at the top.
Yeah, you recovered the RTP header for the packet that was lost via the
So this is the payload.
Yes, before this, yeah.
Right. So like if we're sending this again with effect, as the RTX header, when we're taking like 80 bits for something that previously only took 16. I guess it's in addition to the RTP header. I mean, if we're doing this work, it'd be great to solve this other problem too. I just would recommend we have a different, more compact format for the RTX, which it might make people. All right, ducking.
Yeah, we just added. I think this.
Yeah, I mean, Jonathan, I mean, if you're killing, I mean, obviously you're. I mean, the other thing this does get you, over what RTX has is you no longer have to do SSRC groups for the RTXs, which I think is also potentially a big win because the SSRCs are in the payload format. So I think that the disambiguating that in the wire, you don't need to have anything to figure out which RTX goes with which original source anymore. It's just all there in the format. So I mean, in the context of WebRTC, I think that's also a win. So which is 32 of your bits there. I mean, I kind of feel like
I think the reserve bits and the
reserve
that 32.
Yeah, I mean, if there were a way that we could, I don't know, steal a bit somewhere to say,
I think that bit is coming.
What?
That bit is coming.
Okay, yeah, I mean, because I mean,
I don't.
Yeah, because if we could kill the SSRC count if it's 1, that might be.
Yeah, there is a bit now available.
Oh, yeah, that's what I was going to suggest. Is not make it RTX specific, but make it. I only have 1 SSRC in here specific.
Yeah. Okay. I think we will have to re-engineer something that I was slightly opposed to, but yeah. Let's go back to slide the next one after this one. So open issue. So we put MSK in the top. And when I was redoing the calculation for across SSRCs, I realized that if we set MSK at the top, that means that we would have to apply the MSK to all the SSRCs that we use, and that was a big shortcoming because you might not want to use the same bit mass for same size bit mass across all SSRCs. So the idea became to move the MSK bit from there. And put it into the SSRC bits within each header. Next slide. So what we did was we changed the 2-bit MSK into an F bit, which would say that if it uses a fixed bit, use mask. If you set it to 1, you use bit M and N. Now we have that other bit which was set to 0 all the time can be used for SSRC count. So I need to do this magic. We might get something there. But so the proposal came out that if you change that F bit, which would be either mask or use MN. Next slide, please, Ronnie. Next slide. So if F is set to 1, the header becomes exactly this. SSRC count defines this, and then you have M and N and basically SN base. So that's a fixed MN offset across all SSRCs that you want to use. Next slide.
Wait, blah, blah, blah.
Sorry. How do you know? Is it from the signal? You know how many packets totally in column when using MNN?
You would have all the you would have SSRCs.
Yeah, but I mean within one SSRC, how many packets from this SSRC is included?
That's what the MNN would tell you.
Isn't that the jump step, or is it?
Like only M is the jump step. The M is the row and N is the jump set. Or maybe M is the jump set and N is the.
No, it's so M will tell you for a row, M would tell you how many packets are in that row. If it was a column, M would tell you the stride, and N would tell you the
Right.
column number. How many columns?
Yeah, that's why we didn't use the values L and D, because I think people got confused with L and D, which actually tell you what is the block size. Next slide. So if you set that F bit to 0, then you have the chance to say, okay, so we use bit masks, and since we had these 3 bit masks before, we decided that we would play this pyramid game, which starts with, if you want to use a 15-bit, you say the first bit, and after the SN base tells you there are 15 bits after that. So you're protecting only 15 bits in this case. Next slide. Then the next one tells you it's 31, so it's 32 minus 1. So this would protect the 46-bit case. Next slide, Ronnie. So the next one is 64 minus 1, and this is extensible, so you could go on, but we stopped at then one more, Ronnie. And we stopped at 128 because then we thought this was like we didn't have enough space for the payload. So, so we could stop already at the previous one, but yeah, if you want to protect something like 235 packets, then here you have it. But as in, this is just a proposal, and I'm not sure if people want to play this k-bit, like having a bit which goes on, which doubles in size. So you're okay with the k-bit game then? Okay.
Jonathan, my only concern is that I think we need to make sure that, and then this can possibly be in the SDP, and maybe you already do and I haven't read it, that the receivers have some notion of how big a buffer of received packets they need to keep. Because, I mean, if the k-bit is infinitely extensible, you don't want to force receivers to save every packet they've ever received in order to do recovery.
No, I think that's why I think we just put one extra just to see if where people would...
Even 235 is getting a little...
Yeah, so I think we can
scary.
stop at 108. That's
Okay.
where I think we wanted to stop, and then we said, but what if people, because earlier was 112.
You know, I guess, yeah, I mean, I guess then, and the M&N scheme is such, it will cap out at 255, right?
Right.
So maybe 235 is comparable to that, because somebody could go up to 255 with the M&N scheme.
Right.
Also.
No, M&N goes to
Like actually the...
55.
But it's only
64K.
It's only 255 packets out of the.
It's 255 times 255. M and N. M times N is the maximum. But we don't have a number of packets currently specified in SP. We do have a time window. There's a repair window, the same as spec frame, the same parameter as spec frame, a repair window, and it's in milliseconds. Actually, I think it's in microseconds.
Yeah, it's in microseconds.
So if we think that we should have a packet level indicator, that's good feedback to have.
So
Okay.
should we go all the way to 235 or stop at 108?
Figure out a use case.
As in 112 was okay, so stopping at 108 is not all that bad. So let's stop at 108 at least.
Okay, so that's it for the notes. Stefan?
108.
108.
Put that down.
Yeah, so actually go back, I think we can figure out how, like if you go back one, so since we have this one bit from the MSK saved, I think we could do a case where if you set that to 1, it would mean that there is no SSRC count and we might recover some.
And no.
That's such count reserves.
Right, so just say 32 at least. Or if you want to make it really retransmission, then we could just say SSRC and yeah, everything's there. You don't even need the
sequence number base or the mask.
Yeah.
It needs to be, well, you need to think of the base.
Yeah, that's the always original sequence number. And you need the SSRC because if you want to transmit it in the same session, you need to point to the original SSRC.
Yeah, but you could say like no mask or nothing.
Yeah, but a mask does, yeah, okay, it saves you to 16 byte, 16 bits. So, yeah.
Okay.
I'll see what I can do and maybe just keep the 16 for now. And if, yeah.
John, thanks. I mean, the other possibility, and maybe we've talked about this before, I don't remember, is how useful is it to have TS recovery be a separate field rather than, I mean, like, you know, ULPFEC just, I believe, just plops the TS in, you know, TS recovery in the RTP timestamp header. I mean, this makes the RTCP statistics for this nonsense, but I'm not sure. It's separate streams. I'm not sure.
Unless we move the TS recovery, I think there is text right now says how we do it.
Yeah, no, so it's in your field there. I mean, I'm just.
Yeah, but there's also recovery process. There's a section on it which says how to use it. So,
yeah, I mean, clearly you need to be able to recover the original timestamps. Because the question is, do the RTP timestamps of the FlexSpec packets themselves have to mean anything? Yeah.
Yeah.
In what clock? I have no idea. So I mean, I'm just throwing it out there as a way you could save another 32 bits, but I'm not sure how. I think there is some benefit to not having absurd RTCP reports for this stream, but I'm just not sure how much.
This Magnus. I think if you actually, this makes more. I mean, you don't need length recovery when you're doing retransmissions because that will be implicit, and then you can put the sequence number, original sequence number, in the length recovery field.
That's what it was before.
Yes.
So we're now going back to like having.
No, but just for this, yeah, for this particular setting.
Yeah,
yes.
I think we're going to change this, and this is why I didn't want to have that one bit, because it changes the proposal to actually have two payload formats.
Yeah.
And at that point, you could easily say that write this into another spec.
Yeah.
And
yeah, but that would get you up to 64-bit saving, but that's
Okay.
Okay. I think the authors will reconsider what we've. Okay, and when we had the MNN, we figured out that there's a end condition, like which I think Magnus just alluded to before, that how do you know if there is row and column FAC and if there is more column FAC coming in? One of the ways we thought we could do it is if m equal to 0, m greater than 0 and n equal to 0 is just one row. But if you want to say indicate that there might be columns coming because you had a burst loss in this row, to indicate that this operation is not yet done, there might be more FAC packets coming. You could indicate it as n equal to 1, so that the receiver has some idea of closing the operation on the FAC or not, as in giving up or not. And I think this is a sensible extension to do and fairly simple. And it disambiguates the previous scenario where n equal to 0 or n equal to 1 both meant a row FAC. Now there's a way to say actually n equal to 0 is just a row FAC, no column, and n equal to 1 means a column might come. And yeah, I think next steps are fold in on all the changes, modulo the ones that we discussed today. I think there's still some more work to be done in this, because if you need to like engineer some of the retransmission stuff, that requires some more like wrangling with the headers. But some sections that were in sync and now are totally out of sync are the recovery for the RDP header and the RDP payload. This since the fields have moved about and new fields have been added, this actually is now totally out of sync. So before I fix these sections, I think we need to at least agree that we are happy with the header format before going back to.
So I have a scary question, which is header extension recovery.
Do we care?
Sometimes audio levels, probably.
Oh. I think that the RTC web fact should say something about that.
So what's actually considered payload here is actually the CC list down. So it's actually CC list plus header extension plus payload.
Okay.
All of that is considered payload from the point of view of the FAT code.
Okay. Okay. So now you have work to do.
Yes. Well, I think we still have some more work to do before we do
Yeah,
this
there's
question.
the open issues that you need to resolve and tap them. Okay.
Thank you.
Thanks. The VP9.
Hi, I'm Stefan from Google. I'm going to present the updates we've done to the VP9 payload format since the last IETF meeting. So there are basically two major changes.
Don't let you use this color.
Yeah. Valid point. Yeah, I will explain what it says. So first of all, we implemented this and ran some tests, after which we discovered that we had some ambiguities in the current specification of the non-flexible mode. So basically, we were trying to implicitly derive the temporal index of a frame based on the structure in the SS format that we are sending with each keyframe, and the GOF index, that or basically group of frames index that we have in the RTP header of each packet. If we lose that SS data, we have problems with where we could potentially misinterpret the packet as being temporal layer 0 instead of its true temporal layer index. To get around that problem and to also make the spec a bit nicer, we decided to replace the GOF index in each packet with by explicitly writing down the temporal index instead. So instead of the GOF index, we can calculate a GOF index based on the picture ID of each packet and the picture ID of the packet or the frame that contained the latest SS. So basically the difference between the two, modulo the SS length or the GOF length, would be the GOF index. For the flexible mode, we also decided that we didn't need to be able to refer more than 128 frames back. In the 0.0 draft, we actually allowed to extend the PDIF, which is basically a pointer back to previous frames for reference. We decided that we could extend that from 6 bits to 15 bits, which is a bit excessive. So we removed the extension bit and the extended PDIF field. So now we have a fixed PDIF of 7 bits. So this is, if you can see, the sorry? Yeah. So what has changed is basically the GOF index that has been replaced with the T field, which is the temporal index, and a U field, or U bit, which basically means upgrade. Next slide. And for the flexible mode, we have removed the extended PDF field and the XBit. Next slide. So we still have some open issues to resolve in an upcoming draft version. We have to decide whether or not we want to support in-bit stream simulcast, or where if it's enough to have simulcast with where each stream has a separate SSRC. We have to write down the offer answer considerations that's currently has to do in the draft. Yeah, we have to add a reference to the VP9 bitstream format, and probably have some short description of it in the draft as well. Sorry? Yeah, that seems like a requirement for that. We also don't currently describe how RPSI and SLI are supposed to be used with VP9. We did describe that in the VP8 format draft. We are considering removing at least the SLI part from VP9, since it's not really used by anyone with VP8, and it's even less clear how to use it with VP9. RPSI we might still keep. We'll have to discuss that. And lastly, we have to specify how FIR are used with VP9 when we're running in the SVC mode. And we also, depending on what happens with the LIR draft, we may or may not have to add some text about that to this draft. Questions?
Okay, thank you. Now we have the interleave.
Good afternoon, everyone. I'm Rachel Huang from Huawei, and this topic has been discussed in the last IETF meeting, and we have we received some comments and issues, and we made some changes and to improve the quality. And this time, I'm going to talk about this. Next, please. Firstly, let's have a brief recap of what the interleaving payload is. Basically, interleaving payload is a proposed common RTP payload format for interleaved medias. It is independent of any codec, and it is useful for network environments where interference is an issue, for example, DSL and wireless network. And it is very applicable for non-interactive applications where certain delays is allowable. For example, IPTV. Please. Yeah, in this version, we did some changes. The first change is that we specified interleaving lengths and interleaving depths. Interleaving depths is a packet number of interleaving separation between packets or data originally adjacent. Interleaving depth is the interleaving separation count of an interleaver output buffer. We also specified packet interleaving and data interleaving. For packet interleaving, it simply permutes the RTP packets for transmission. And for data interleaving, it can segment RTP packets into pieces, then disarranging them and reassembling them into new RDP packets, and it can also aggregate several RDP packets into one RDP packet for transmission. In data interleaving, the number of separations of one packet is equal to the interleaving depths. For data interleaving, also interleaving it may change the number of RTP packets during transmission, but the number of RTP packets will be recovered after the interleaving. So we also specified IANA registration and some clarifications as well. For example, we only the packets of the same one RTP stream are allowed to be interleaved in one interleaving stream. Next, please. In the previous discussions, the biggest concern is that how does this mechanism help? Here, we illustrate the rationale. From the figure, we can see that interleaving can work with FEC to increase the recovery possibilities, especially when continuous loss happen. Yeah, we all know that FEC may become difficult to recover packets when meeting continuous losses. However, when using interleaving, continuous packet losses will be dispersed into isolated ones, so that the losses can be distributed into different FEC range, so that the recovery possibilities could be greatly improved. Next, please. Here we did some experiments to show the results. In this experiment, we did three types of tests. The first one tests only interleaves iframes. One test interleaves all the frames, and the other does not do interleaving at all. From the figure and pictures, they are not maybe not very clear, but we can see that the test interleaving iframes has the best video qualities compared to the other two, even if it only with less FEC traffic. Generally, the tests interleave all the frames are have better quality than non-interleaving at all. So it shows that interleaving can improve the video qualities. Next, please. Yeah, doing interleaving definitely will increase the processing delay. In this experiment, we also compare the delay of only interleaving iframes and the delay of interleaving all the frames. And we can see that interleaving iframes reduce the processing delay by 90%. So, from all these experiments, that we can see that doing proper interleaving does have benefits for improved video quality or media qualities of applications. Yeah.
Varun Singh. So I had a question more related to to the previous slide where you say FEC was used. I was curious, was this row FEC? Was it what kind of FEC was it?
What kind of it's no matter what kind of FEC we in this experiments we use the algorithm, I think COPS3.
Okay, because you can either interleave the data packets or you could interleave the source packets that you protect, and that's similar. I'm wondering if the two things would compete with each other if you interleave the source packets and also interleave the packets.
It's interleaving. This experiments interleaving the source packets.
Okay. It seems as if they were just like row FEC, and then you have burst losses. Then the FEC would not actually be able to protect it. And what you're saying is that if you interleave the packets and you had row FECs, then if there were packets that were interleaved and they got lost, then
yes,
and then they would be recovered because they would be isolated.
Yeah.
So
yes.
I'm wondering if you used an interleaved FEC, you would get the same behavior. So
Depends on the size of your FEC block, right?
right, and the example was 5 × 5 in the next one. So
Yeah.
I was just speaking to the results that I'm seeing. I'm like they seem not to make the case entirely.
Oh, so maybe.
Or at least they're like a situation where you would say like both of them are similar in performance.
So you're saying that there should be also try to do the FEC on the interleaved on the interleaved and not on the source packet, or to interleave the FEC and not the source.
Like do the same thing that you think that you're trying to do with the interleaving. Do the same pattern in the FEC and see what happens.
I think, Stefan Wenger, I think the fair comparison that should be made here is, since this stuff basically adds, say when you have this 5 + 5, it adds a 10-frame delay,
Yes.
right?
Yes.
Then the fair comparison to make would be, what's the performance difference between having interleaving and a 5-packet FEC frame? FEC, what was it? Yeah, vis-a-vis just a 10-packet FEC with twice as much protection, right? And information theory tells me there's not really a big difference, if any.
Yeah.
Except that FEC is actually better when you have a large FEC block and operates better when you have a large FEC block and can use a more complex code than when you have a naive FEC, an XOR FEC with only like 5. So yeah, sorry, but I don't see a value there.
Okay, maybe we need more work to do. Maybe another additional experiment to compare it.
I don't want to send you out to make experiments. I want to send you out to make a theoretical analysis why using this type of hard-coded interleaving plus small FEC blocks is better than big FEC blocks. That, you know, that's nothing which where you need to do video coding and all that stuff. That's a really simple theoretical analysis that's needed here, I think. Thank you.
Magnus Westland. I mean, from my understanding, normally for a reasonable FEC code, you would actually, I mean, yes, FEC creates overhead. Interleaving creates very little overhead. But as the packet loss rates goes up, the FEC actually repairs it, and the quality should be, you should have a lower starting base quality with FEC, but you should actually be able to, they should cross at some point. As long as you're giving the same protection. I mean, if you're saying that you have 10 frames of interleaving, of course, then FEC should be able to use the same time interval for protection. Doing something shorter, which this can't protect as well against block losses, it's not fair. So
I was just going to re-echo what Stefan said, because I think, yeah, this is fairly simple experiment, and as in thought experiment. At least from the results, it seemed like a bit non-intuitive to me, or at least seemed similar. So that's why I came up to make the remark. So I think something just to show where this would actually work and say how it's different from like using FEC would be definitely useful.
Okay. Yeah.
Justin, you ready? I'm not super familiar with all the details, but I was just reading over the document, and one thing I would suggest would be changing the MIME type you've registered. The choice of words is somewhat unfortunate here. That GENITL is very close to an English word that has a very bad meaning. So I suggest pick something else.
All right. Okay. Okay, I believe. Sorry.
Okay, any other comments? Okay, thank you, Rachel. So this was the last presentation for Payload, and we'll see you in Buenos Aires probably again. And you can enjoy the social, whoever is going there. Thank you. If anyone didn't sign the blue sheet, they are here.
It's actually we had something in some of the papers, and that was because slides, small slides, that didn't work. It should be very straightforward to come up with a description of why this good. If there is what do you say? There was a lot of yeah, I have paid relatively so I definitely have I think all the decisions not much beyond yeah. This is also but stuff to do it that it goes way too much in the direction of I love that entirely video yeah, well, so that's actually something which I'm not too worried about. That I could definitely no. Now we have this thing that they want to have different.